Good day, students. On this clip, we're going to be going over two examples on how to find the dot product of vectors um, algebraically and geometrically. Okay? All right, so let's go ahead and write down the instructions for question one. So actually for one and two. So A part, what we're going to do first is find the given dot product um, algebraically and state the meaning of your result. And for the second part, part B, you're going to do the same thing. We're going to find the dot product using a different method. So find the dot product, um, geometrically. Okay, so hopefully our answers match in the two methods, and then we'll be confident that our answer is in fact correct. Okay, all right, so let's go ahead and take a look at the question one. Question one, we're gonna find vector A dotted with vector B, where vector A is root 3 comma 0 and vector B is root 3 comma 1. Okay, all right, so first thing we're going to do, let's do the A part. We're going to do the algebraic method. Okay, algebraic method. All right, so for the algebraic method, um, let's first of all state what the formula is. So for the algebraic method, if you dot A dot B is equal to A, the x component of A, comma the y component of A. This is a representation of vector A, and then we're going to dot this with the x component of vector B and the y component of vector B. Okay? All right, so there you have it. So what does the arithmetic method tell us to do? Well, for the arithmetic method, all you simply do is you multiply the corresponding coordinates and then you add the product. All right, so it's the x component of vector A multiplied by the x component of vector B, and then we add that to the product of the y component of vector A times the y component of vector B. Okay, so this is the algebraic method. Okay, all right, so let's go ahead and apply this formula to the situation we're dealing with right here. So in the problem we have a dot b is equal to the square root of 3 comma 0 dotted with the square root of 3 comma 1. All right, so what this formula tells us to do is multiply the x's and the y's and then find the sum of your product. All right, so we're going to do root 3 from the x coordinate of the x component of the first vector times root 3, the x component of the second vector plus the product of the y's, 0 times 1. Okay, so root 3 times root 3 is root 9. Root 9 plus 0 times 1 is 0. Square root of 9 is 3, so our final answer is 3. Okay, so what is the meaning of this? So the meaning is, remember your coordinate system. The angle between the two vectors is between 0 and 180, right? Between 0 and 180. And we know that all trig functions are positive here, only sine is positive here. So we know that if the result we get is positive, that means that the angle is less than 90 degrees. If the result is 0, then we know that the angle between the two vectors is exactly 90, and if the result is negative, we know that the angle between the two vectors is greater than 90 degrees, okay? So in this case, we have a positive dot product. That means that our angle is going to be between 0 and 90 degrees, all right? So it's going to be less than 90 degrees, okay? So the dot product, since the dot product is positive, dot product is positive, um, the angle between the two vectors is less than 90 degrees. Remember, if it's 0, it's exactly 90 degrees, and if it's negative, it's greater. All right? Okay, we've accomplished our goal using the algebraic method. Now we're going to do the same process using the geometric method. Okay, so part B is the geometric method. All right. Okay, let's state what the formula for the geometric method is first, and then we're gonna apply it to the situation. Okay, so for the geometric method, vector A dotted with vector B, we don't need components here, it's simply the magnitude of vector A times the magnitude of vector B times the cosine of the angle of separation between the two vectors. Okay, so this is the formula. All right, so in this problem, we know that vector A is square root of 3, comma 0. Now, how do we find the magnitude? We just basically apply Pythagorean theorem. So we know that the vector itself is like C, the hypotenuse, and the first vector is A, and the next vector is a B. All right, so we're going to use C squared equals A squared plus B squared to find the magnitude of this vector. All right, so we're going to have the magnitude of vector A square, so that's C squared equals A squared, which is root 3 squared, plus 0 squared, which is B squared. Okay? Alright, so we're going to have the magnitude of vector A squared equals root 3 squared is 3 plus 0. Okay? And then we'll simplify that magnitude of vector A. So to get the magnitude of vector A by itself, we'll take the square root of both sides, right? So magnitude of vector A squared equals 3, and then you take the square root of both sides, and that will be the magnitude of vector A. So the magnitude of vector A is simply the square root of 3. Okay? All right, now we're going to go ahead. Remember, for the formula, we need magnitude of vector A. Now we need to find the magnitude of vector B. Okay, so vector B is root 3 comma 1. So the magnitude of vector B squared equals, we're using Pythagorean theorem again. Remember, the vector is C, and this is A, and this is B. So we're going to use C squared equals A squared plus B squared. So this is C squared equals A squared, the x component square plus y component square plus 1 square. Okay? So the magnitude of vector B squared equals, root 3 squared is 3 plus 1 squared is 1. So we have magnitude of vector B squared equals 4. Alright, to get the magnitude of vector B by itself, we'll take the square root of both sides, and that yields, tells us that magnitude of vector B equals square root of 4, which is 2. Okay? So we now have the magnitude of the two vectors down. Now, next thing we're going to do is we want to find the angle of separation, the theta. Okay, so in order to do this, we actually have to graph these two vectors. We're going to graph vector A and graph vector B. All right, so let's go ahead and make a sketch. It doesn't have to be perfect. We're going to graph the two vectors, vector A and B. So let's say vector A is root 3 comma 0. Let's just say 1, 2. All right, so this is not drawn to scale, so let's just say this is root 3 right here along the x. And so root 3 comma 0, the first vector will be right here. Let's draw that in. Here goes the first vector, root 3 comma 0. Let's color it red. Make it red. So this vector right here is vector A. Okay, so this is vector A, the one in red. Now, we're going to graph vector B, which is root 3, and it will go up 1. Okay, so let's scale it so we don't have a really skinny triangle. Let's call this 1 right here. So to graph vector B, we're going to go root 3 to the right, and then we're going to go up 1. Okay, like we did in the previous lesson. So let's graph vector B. I'm going to make it blue. So there goes vector B right there. Okay. All right, now we have vector A and B drawn. Now, what are we looking for? We're going to be looking for theta. This angle of separation right there, that's the theta that we're looking for. Okay? So we notice we can make a right triangle. Make a right triangle. I just connect these two sides together. So there goes it. We have a right triangle right there. Okay? All right. So now, when I was constructing this triangle, we went root 3 to the right. So we know that this side length right here is root 3. And then going up, we went up only 1 unit. Okay? So go up 1. All right. Now, using right triangle trig, we know that the side opposite the angle is your what? Is your opposite. All right? And then the other side, this is your adjacent. So in order to find theta, we're going to have to use a trig function that utilizes A and O. And which trig function is that? It's the tan trig function, right? So from Torah, we know that tan of the angle theta equals the opposite over the adjacent, root 3. Okay? So now let's go ahead and get theta by itself. We're going to take the inverse tan of both sides. So the inverse tan of tan theta equals the inverse tan of 1 over root 3. 1 over root 3. Okay? All right, so let's work that out with our calculators for the inverse tan of root 3. 1 over root 3 is, but before we do that, on the left side, notice that the tan and the inverse tan cancels out. So we're going to have theta equals, now we're going to enter that. The inverse tan, second function tan, 1 divided by the square root of 3. Enter 30 degrees. So theta is going to be 30 degrees here. Okay, so theta is 30 degrees. All right, now that we have theta, we can now plug in these three results into our formula. Okay, so remember in your formula you needed a magnitude of A, you needed magnitude of A, magnitude vector B, and then theta. Okay, cosine theta. All right, so now we're good to go. So A dot B, using that formula up there, A dot B equals the magnitude of vector A, which is root 3, times the magnitude of vector B, which is 2, cosine theta. Theta is 30 degrees. Okay? Alright, so we can do this by hand. This equals root 3 times 2 is 2 root 3. Cosine 30 degrees is root 3 over 2. You can check that out using your chart. So the 2 and the 2's cancel out. And then root 3 times root 3 is root 9, which equals 3. Okay? So we have the vector A dot B equals 3. Alright, so is that what we have in our original answer in method 1? Absolutely. We had a 3 and we have a 3. Our answer is matched. We're now confident that the result is in fact correct. Okay? So that's that. Alright, now let's go ahead and take a look at another example, question 2. Now we're going to find A dot B, where vector A is 3, 3, and vector B is 3, 0. Okay? Alright, now we're going to do the algebraic method. Algebraic method and state the meaning. Alright, so algebraic method. What is the formula for the algebraic method? Let's write it out first and then go ahead and solve it. So if we're dotting two vectors A dot B, because basically we're doing x and y component of A dotted with the x and y component of B. Alright, so the dot product in the algebraic method is you multiply the x component of both vectors in 2D, and then you add it to the product of the y component of both vectors. Alright, like that, and that's it. Okay, now let's apply that to this problem. A dot b, we have vector a is 3, 3, dotted with vector b, which is 3, 0. So we're going to have 3 times 3 plus 3 times 0. Alright, and then 3 times 3 is 9, plus 3 times 0 is 0. We have 9 plus 0 equals 9. Okay, so this is the dot product of the two vectors. So what does this mean? What is the meaning of this result? Meaning, since the dot product is positive, then the angle between the two vectors is going to be in the first quadrant, which means it is less than 90 degrees. Okay, so there you have it. All right, are we confident that our answer is correct? Well, let's do it in a different method, using the geometric method. Hopefully we end up with the same result. Okay, all right, so we're going to do this using this is the A part. The B part, we're going to use a geometric method. All right, so geometric method. All right, so what is the formula first? Let's write down the formula so we can find the relevant components we need to compute the dot product. So A dot B, using the geometric formula, is simply the magnitude of A multiplied by the magnitude of B multiplied by the cosine of the angle of separation between the two vectors. All right. Okay. Now, vector A is 3, 3. We're going to find the magnitude of vector A using the Pythagorean theorem. All right. Remember, the vector is like the hypotenuse C, and then we can call this A, B. Okay, or VA, doesn't really matter. Those are the legs. So C squared equals A squared plus B squared. C squared is the magnitude of vector A squared. The length of this vector is the magnitude square, equals A squared is 3 squared plus B squared, which is 3 squared. Okay. Now to get the magnitude of vector A squared, let's simplify the right side. So the magnitude of vector A squared equals 9 plus 9, which is 18. Okay. Now we're going to root both sides. Square root of this, take the square root of that. And then the magnitude of vector A squared, the square root of that is the magnitude of vector A, which equals the square root of 18 is 3 root 2. If you break this down, it's going to be 3 times 3 times 2. The two 3's come out as a 3, and then you have 3 root 2. Okay? All right, now vector B. We need to find the magnitude like the formula indicates here. So vector B is 3, 0. So magnitude vector B squared equals, we're using Pythagorean theorem again. So remember, this is C squared that I just, this is C. And this is A, and this is B. All right, so we're having magnitude of C squared. C squared is the magnitude of vector B squared equals A squared plus B squared using the Pythagorean theorem, so we have 3 squared plus 0 squared. All right, so the magnitude of vector B squared equals 9. So to get the magnitude of vector B by itself, we'll take the square root of both sides. Square root. And then you have the magnitude of vector B equals the square root of 9, which is 3. All right. Now the last thing we have to do is find theta. All right. To help us find theta, we need to use a right triangle trig. So how about we do a sketch of the situation, and then identify the relevant components of the right triangle that can help us find what theta is. Okay. So I'm going to go, let's say 1, 2, 3, 4. Let's call that 3. I want to draw vector A. Vector A is 3 to the right and 3 up. So 1, 2, 3, 4. Let's call that 3 also. This is not being drawn to scale, as you can clearly see. So this point right here is the tip of vector A starting from the origin. All right, so we're going to go ahead and draw vector A. Let's make that blue. So there goes vector A. All right, label vector A. Now let's go ahead and sketch vector B. Vector B is 3, 0, so you just go 3 units to the right on the x-axis. So let's draw that one in red. So there goes vector B. Okay. All right. Now we're looking for theta, the angle of separation between these two vectors. Okay. So let me form a right triangle, see the parts I can determine, and then use the right triangle trick to finish it off. So there goes my right triangle right there. We have the opposite. The side opposite the right angle is called the opposite. Right? How long is this? This is 3 units, so we know this is the opposite, and that's also equal to 3. And this, we went 3 units to the right, so this is the adjacent, and that is also equal to 3 units long. All right, so where trig ratio relates O and A is from SOHCAHTOA is tan, right? So tan theta is equal to the opposite over the adjacent, okay? All right, so tan theta equals 1. So tan theta equals 1. To get theta by itself, we'll take the inverse tan of both sides. So the inverse tan of tan theta equals the inverse tan of 1. Okay? All right. Now, a tan and the inverse tan cancel out. So theta equals the inverse tan of 1. We know that's 45 degrees, right? But let me just show you my calculator real quick. Inverse tan of 1 is 45 degrees, okay? So the angle of separation between the two vectors is 45 degrees. So now, we now have all the components we can assemble to find what the dot product is, okay? So A dotted with B equals magnitude vector A, which is 3 over 2, times the magnitude vector B, which is 3, cosine theta, which is 45. All right, so let's see what this is. So we're going to have 3 times 3 is 9, so 9 over 2. And if you use your chart to figure out what cosine 45 is, cosine 45 is root 2 over 2. So what we're going to do now is multiply, okay? So we're going to multiply across. So we have 9 roots 2 times root 2 is 2, right? So we have 9 times 2 over 2. So the 2 2's divide out. So we have the result A dotted with B equals 9. Alright, so is this what we got earlier using the algebraic method? Absolutely, that's what we got. So we're confident that our answer is in fact correct. Alright, so there you have it. Thanks so much for taking the time to watch this presentation. You can feel free to subscribe to my channel by clicking up here. Please post a comment to tell me what you think about this clip. I really appreciate it. And click like if you like the video down here. More clips can be found on mycoachserve.com. Thanks again and have a wonderful day.